right, amazing. So I hope everyone's having a great conference. I certainly have myself. It's absolutely fantastic to be here. So thank you for having me. I think I've got about 20 minutes to run through maybe like an oyster talk. So not enough to teach you a lot about serverless, but certainly enough to plant a seed for you. So who am I? My name is Liam Hampton. I'm a regional cloud advocate based in the UK for the Microsoft Reactor. So hopefully some of you have been to the Reactor here in Tel Aviv. It's absolutely fantastic. You've got an amazing startup community here. I'm an Auth0 Ambassador. For those of you who don't know what Auth0 is, it is a security company. And it is one which I embellish because security is something that developers don't necessarily think about all the time. I'm also a Dev Network Advisory Board member, so I like to organize hackathons, and I like to see how they're judged and work with conferences as well. So I'm not going to go through any more. I'm going to crack on with it. So, short agenda. What am I going to talk about today? So we're going to go through a 20-year timeline as to where we've come from and where we are today throughout the past 2 decades with serverless and compute power. We're going to talk about what serverless actually is, because I appreciate, having spoken to a lot of developers, people don't necessarily think or understand what it is at a deeper level. I'm going to look at some challenges because I've been writing serverless functions for the past about a year now, and I come across a couple of pitfalls and a couple of challenges myself. And I'm going to look at some examples, something which I've written, something that I've created, and I'm going to share with you today. And then I'm going to answer the infamous question, is DevOps dead? Now, I always get asked this question when talking about serverless, and I'm hopefully going to give my best answer to you, and we'll go from there. So, who in the audience is brave enough to tell me how much they think it costs to start a tech company in the year 2000? Anybody? Just shout out. $1 million. Okay, not far off. It actually cost $5 million. I say not far off, pretty far, but you're in the right ballpark. Okay, it cost roughly $5 million in the year 2000 to start a tech company. That is a lot of money, and not many people had that lying around. So where did it all begin? We had on-premise racks. We had servers, which companies had in their back room. They had them under the stairs. They had them in all sorts of places. But that was a capital expenditure. That's basically a fixed asset which companies were basing or putting their money into and letting it run its lifetime. If that was to break, that is all on you. You have to fix that. That's expensive. If it needs updates, you need a whole team to be able to do that. They're consistently on, so you got to think about utilities. What about your electricity bill? That is really expensive, but that's where we were about 20 odd years ago. Then we moved to virtual machines, and this was a bit of a gray area. This is where companies thought, we have got some servers. Let's put a couple of machines on there and let's try and use what we have already. But then you also had the flip side of the movement to cloud. Okay, and this is where people were renting virtual machines, where you pay per machine or per hour, sometimes even granular. And this is where you had the multi-tenancy going on sort of in corporates and cloud there. We then moved to containers. And containers were, a package of code, and it was lighter than the virtual machine. It's a smaller version. It's more disposable. People can throw them away. It's a better way to develop. And again, this was based in the cloud. You're now paying per service, and per service means that you're degrading or lowering your cost each time we go through this timeline. And this is where we have multitask and, containers. So 2013, 2014, you had Docker, you had Kubernetes, and this is when it was using the hypervisor and your host operating system. So you kind of had all the power available to you, but not necessarily something which you want to be using. And then we had serverless. What is serverless? Well, this technically started in 2014 with AWS Lambda functions and step functions that came later on. But it really started to take off in 2017, 2018, when we had this whole movement of event-driven architectures. So I'm going to ask the question, what is serverless? And like every single presentation you'll see, there's a disclaimer. Servers are still involved. If you were to Google what serverless means, then you'll get some word spaghetti. You'll get quite a lot on Google, lots of different explanations, giving you around about the same thing. But I care about 6 words out of this whole paragraph. Cloud service provider manages the infrastructure. Period. That's basically an overarching umbrella of what serverless is. Quick show of hands. Who has seen the shared responsibility model before? Okay, so about 20, 30% of you, maybe some people who haven't. I'm going to run it down for you. So the white blocks are developers, they're you and I, and the gray blocks are service providers. So think about big cloud service providers. This is where you can show diminishing responsibility across different architectures in your data centers, across your architecture, everything that you've got going on. So on-prem, already mentioned, servers. You are 100% responsible for all the servers and everything that happens between the data layer and your information that's stored on there, all the way down to the networking and physical data center. If you move to a SaaS model, if you look at Office 365, for example, you are then, well, you've got less responsibility as a user. You are caring for the data and only the data and the devices that can connect to that service. But you don't care about the physical data center and where that data is actually stored. That is all down to the cloud service provider. So where does FAST fit in? So FAST being function as a service, or serverless, as some might say. Well, I believe after my research and what I've been looking into, because there's no hard sort of way of saying this, but I believe it is in PaaS, which is platform as a service. What does that really mean? Okay, what does serverless really mean to the everyday developer? Well, it means that we don't care about provisioning servers. We really don't need to worry about that, or so it seems. We're going to dive a little bit deeper as to why a little bit later on. We also care about automatic scaling, so elasticity. How does it go up and how does it go down based on usage? So horizontal scaling. Again, we're going to look at that shortly. We only care about paying for the execution time only. Okay, so as a developer using cloud, this is pretty much the basis of cloud, of just paying for what you use. But now it's got even granular. So instead of paying for a service, you're now paying for code execution time. And that can be anywhere between sort of a couple of 100 milliseconds up to a couple of minutes. And finally, we care about high availability and fault tolerance. So if something was to happen to a data center, you are not responsible for that. The cloud service provider is, but making sure that you still have access to what it is that you're trying to call with your function, your execution, that's what you care about, and you should still be able to do that. It should be highly available and fault tolerant. So let's dive a bit deeper. Let's look at this Docker container. So in this Docker container, I have got a program. It's packaged up. We've already established that. We've got three functions. We have got the home route, we have got the payment function, and we have got the load dashboard function, and they all do something. However, if I want to make a really small change from hello developers to, I don't know, something else, hello developers at DevOps Days Tel Aviv, right? I care about that one line. If I was to then redeploy this, I need to build this whole Docker container again. I need to deploy it or run the build cycle, everything, just for one small change. If this was serverless, because these can all be event driven as a function, you can notice here I've got version 1, version 2, version 3. I can change that hello developers to be a separate line of code, and it will be version 3. But as long as the functions are versioned individually and have a common interface, they can all still connect and talk to each other. Okay? So that is pretty much what serverless is trying to aim and achieve at this point. We want to move out of this whole, I guess, not necessarily a monolithic, but a packaged, versioned architecture of containers and break it out into versioned code. So what are some of the challenges that we face with serverless? Because, hey, it sounds really great so far. Well, no, there are some problems. Long-running processes. Okay, if you're going to migrate to a serverless function architecture and you're coming from containers, well, you might have some processes which last longer than 10 minutes. Now, that's a bit of a problem because, especially with Azure and other cloud service providers, there's a maximum execution time on their functions. So Azure has a default of 5 minutes for your execution, and the absolute maximum is 10. Well, that's a problem, right? If you have a whole container which is doing a lot of things, or maybe crunching some numbers or training something, well then, hey, it might be longer than 10 minutes, so it's not going to be necessarily great for this. TDD is hard, and I'm an avid advocate of test-driven development. But because you're only touching the top of the code at this point, you're only just touching the code as a developer, you don't care about everything underneath. But you are relying on the cloud service provider to give that to you. If you're going to test this locally, you need to emulate what's going on in the cloud. That's difficult because now you've got this whole, we don't care about the infrastructure, we don't care about what's going on, to we actually do care and we need to care because we need to test this. So test-driven development is difficult. Although some of them are making it easier for us, still pretty hard. Thirdly, vendor lock-in. So vendor lock-in has notoriously been a problem with serverless functions because, again, you're touching the top of the code and you're relying on everything underneath it. And that is great when it comes to service providers giving you everything you need to run perfectly in their ecosystem and in their little bucket. But what if you want to talk to something or a service outside of that ecosystem? It becomes inherently harder. Now, that could be because the interfaces don't match up. It could be the data is given to you in a different aspect. It's not necessarily the easiest thing to get out of, although it's getting much better now. And then finally, cold starts. Cold starts have always been a problem, and they are mitigated somewhat now, but it's still something to be wary of. So, an analogy. Imagine you're falling asleep on the sofa. Someone knocks you and says, hey, let's go and do the dishes. Let's clean up, let's do something. You're going to startle. You're going to be like, you need to process that request before you start acting on it. But if you're already actioning something, you're up walking around, typing. Someone says, hey, come on, let's go do the dishes. Well, then you're already ready. You don't need to process that wake up call. Okay, so that's a really good way of thinking about cold starts, servers, and serverless, because it's still run somewhere. It's not just mythically floating around. And there's a common misconception with serverless. It is not just code. People think this. I've seen it. I used to think this, but it's not just code. There are so many different applications that are serverless as well, and you probably don't necessarily realize. So if you want container services, let's look at the three big cloud providers. Azure Container Instance. So say you can't move out of your containers, but you still want some kind of cost management there. Use Azure Container Instances. AWS Fargate, GCP Cloud Run. Some really great services for you to use that are actually serverless, scaling down to 0. Data storage, because people don't also realize that serverless can be incorporated in data storage. So whether it's databases or buckets, so Cosmos DB in Azure, AWS S3, or GCP Cloud Spanner. Some really cool services again. And then finally, application integration. If you want to move things around inside your workflow, you've got Azure Logic Apps, you have got AWS Event Bridge, and you've got GCP workflows. Again, really, really good way for you to incorporate this into your application and your infrastructure at a serverless level. Let's look at an example. Traditional 3-tier application. Hopefully, you should be somewhat familiar with this. You've got a client UI written in, Angular, React, JavaScript, something along those lines, sitting on top of a server, Apache, for example. And then that talks to a database, whether it is MongoDB, SQL, NoSQL, document, etc. It can be whatever you want. But if you want to move this to serverless, you have an event trigger. So whether that's a REST call, data change, a message queue, something happens to make something else happen. It's a knock-on effect like a domino. This would call a function, and it'll be written in your language, whether it is, TypeScript, Go, Python, whatever is supported by your chosen cloud provider, which then talks to service APIs in the cloud. Let's break it down a bit more. This is how I would create it. So a serverless application, written how we just were, client UI in app services, talks to a bunch of functions. Event driven, so whether it's adding something to a cart, whether it's adding something to a catalog or a payment service, it needs to scale elastically. Okay, and it's event driven. That will then talk to a service API of, let's say, Cosmos DB. Okay, it's a really simple example. Now let's look at a real case study, which I've actually built and I play with quite a lot. Imagine everybody in this room up here is watching Satya Nadella present something. Some of those people in that room is going to be looking at their phone. Some of them are going to be looking at the floor. Some of them are going to be looking at the watch, and maybe some actually looking at the screen. I want to capture all of that data. So what do I do when I have all that data? Well, I'm just grabbing it and dumping it, grabbing it and dumping it. That's not necessarily the best way to do it, but it's the most efficient because of what I do next. I have my trigger, which calls a generator function. Now that generator function goes and calls a Wasabi bucket. Now, for those of you who know what Wasabi buckets are, they are S3 buckets. Okay, it's just a wrapper. So I'm already incorporating a multi-cloud structure here. That gives me back the data, which looks pretty awful. You've got a date, you've got what they're doing, you've got a key metric, it's a hash, actually, and it doesn't look very pretty. I then send that to an ASQ, so Azure Storage Queue, okay, as a message. But this is batched up and buffered. Whilst that's growing and buffering, it's then sending it to a delegator function. Now, the delegator function is going to do what it says on the tin. It is going to throw that, and it's going to scale horizontally to other processor functions to process the data into the the format that I want it in. That is then going to dump it straight back into another Wasabi bucket and give it to me in the format I want. Ultimately, looking something like this. Okay, this is really, really good because it allows me to break down a seemingly really long process into smaller chunks, allowing me to build out this application and have it completely serverless. It is multi-cloud. It is broken down. It is efficient. Why did I do it? Well, it's easy to stand up with IAC, so infrastructure as code. It's transferable to different cloud service providers. So, for example, AWS, if I want to put in some functions, so I use Lambda instead of Azure functions, I could use I don't know what the message queue is in AWS, but I could seemingly switch them out pretty easily. It allows horizontal scaling, and it processes thousands of requests at a time. So this is a really good way for me to do what I want to do efficiently and cost effectively. Now, is DevOps dead? Is my main question and what I'm going to answer. So hopefully we all know what DevOps is, stands for DevOps days, but we'll run through 3 bullet points. DevOps is developing and releasing regularly. It is iterating over a common problem. And finally, it is creating automation, ultimately solving everybody's pain of long development cycles. How does that incorporate serverless, Liam? Well, it incorporates serverless in a number of ways. If we're going to be looking at the coding stage, okay, it enhances DevOps. If we look at the coding stage, it is, you're not writing whole stack applications. You are writing single functions to make a bigger application. If you want to look at the deploy stage, you are not just deploying to containers. You can deploy it to a function. Okay, and this service is managed by the cloud, or your cloud service provider, rather. And if you want to look at monitoring, again, it's an even granular monitoring scale. So everybody likes debugging, not. But this is a really great way of finding those problems, those bottlenecks at a really small granular level. I once wrote a language server when I was a developer, and that was just basically going into a function and helping to understand how many ticks a function has and how long code was sat in there. Completely redundant now, because you can throw up the same function into the server, into the cloud, and it will tell me through my monitoring dashboard exactly how long that function was in there for and how many ticks it had. So what is the main problem that serverless solves? Well, it solves your costs. It reduces your costs drastically. You also have the time to market that it reduces. Absolutely fantastic for the business. And finally, it solves development. It improves your development. It helps your functions, or it helps your cycle go quicker and quicker and quicker. And those are the 3 main sort of positives that I can give you from serverless. So if we fast forward 22 years, launching a tech company in 2022, how much do you think it costs now? Someone shout out. Give me an answer. $49.99. You're not far off. You're a couple of decimals off. Roughly $50,000. That is 1% of what it costs 22 years ago, which is amazing. And all through what I have spoken about is the reason why. So you've now got $4,950,000 more dollars to spend on your company Christmas party. Hooray. So much like everything in tech, there's an evolution. There's developer experience improving. Who knows what the next one is going to be? But that is serverless, and that is all from me. And I've done it within 20 minutes. So I am absolutely happy. Thank you very much.